Hello, I'm Khaing and this is my video for Unit 4 mid-unit assignment. And for the first question of the number 1 is this the question and determine the trigonometric equation that model this information that y be the temperature in degrees Celsius and x be the numerical value of demand. So here is the cost function of the grad time. This is a cost function, and the function is the five key point is such as the minimum. So this is a negative cost function. So the general form for a cost function of f for x is negative a into cos into k into x minus d plus c, and we'll find the maximum point is 21 degrees Celsius and the minimum point is negative 24 degrees Celsius. So we'll find A, K, D, and C. So first we'll find K, and the equation of the period is 2 pi by K, and the period is 12 months. So it is 12 and 12 equal to 2 pi by K, and we'll find the value of K is pi by 6. And the amplitude is A, so the equation of the A is maximum minus minimum by 2, and the maximum point is 21 and the minimum point is negative 24. So we'll get the value of A is 22.5. And D represent the horizontal translation, so the value of D is 0, and the equation of the C is maximum plus minimum by 2. So the maximum point is 21 and the minimum point is negative 24. So we'll get the value of C is negative 1.5. And we'll find the trigonometric equation. So the equation of the function is f for x equal to minus 22.5 cos pi by 6x minus 1 by 5. So this for number 1. For number 2 is a field wheel has a diameter of 10 meter and takes 24 seconds to make 1 revolution, and the lower points on the wheels is 1 meter above the ground. So the given is the diameter is 10 meter and it takes 24 seconds to make 1 revolution, and the lower point is 1 meter above the ground. This is the given. And number 8 is we'll sketch a graph. So determine the diameter is 10 meter, so the radius is 5 meter, and for the point to draw the graph, and at t equal to 0 second, the height is 1 meter, and at t equal to 6 seconds, the height is 6 meter because the radius is 5 meters and the lower point is 1 meter. So it is 1 plus 5 meter, so it is 6 meter is middle. And for t equal to 12 seconds, the height is 11 meter because the diameter is 10 meter and the lower point is 1 meter. So 10 plus 1 meter equal to 11 meter is the 12 seconds equal to 11 meter, and for 18 seconds the height is 6 meter, and for 24 seconds the height is 1 meter. So this this a point of the graph, and at 0,1, at 6,6, and at 12,11, and at 18,6, and at 24,1. So this is a cost function graph. And This for number A, and for number B is write a trigonometric equation that describe the graph, and so we'll find the equation. The is a cost function, and the point is such as the minimum, so it is a negative cost function. So the equation is y equal to minus a cos k into t minus d plus c. So we'll find a, k, d, and c. In the graph, the maximum height is 11 meter and the minimum height is 1 meter. So, and the first we'll find the amplitude. The equation of the amplitude is A equal to maximum minus minimum by 2. So the maximum point is 11 and the minimum point is 1. So we'll get the value of A is 5 and the period is 24, and the equation of the period is 2 pi by k. So we get k equal to pi by 12. And the equation of the c is maximum plus minimum by 2. So the maximum is 11 and the minimum is 1. So the equation of the value of c is 6. And this represents the horizontal translation, so the value of k is 0. So the equation of the equation of h of t is negative 5 cos pi by 12 t plus 6. This for number B, and for number C is chat. We'll chat the point t equal to 12 seconds. So when t equal to 12 seconds, and the t is 12, so in the equation the t is h of 12. The h of 12 equal to negative 5 cos pi by 12 into in the t is 12, so into 12 plus 6. So negative 5 cos pi plus 6. Cos pi is negative 1, so the answer is 11 meter. In a graph, in the graph you can see the maximum point is 11 meter, and at t equal to 12 seconds the answer is 11 meter. So the equation is correct. This for number 2, and for number 3 question is given that the height of maximum at 8 hours 21 minutes is 17.3 meter, and the height of minimum is 4.5 meter as 2 hours 8 minutes. It is given, and for number A is assumed that the height of the time can be modeled as a cosine function of the time of day, and then determine the equation in the form. And it's given the equation is h of t equal to a cos k into t minus d plus c. So here is the given equation, and we'll find that a, k, d, and c. So first is the equation of the amplitude A is the maximum minus minimum by 2. So the maximum is 17.3 and the minimum is 4.5. So we'll get the value of amplitude is 6.4, and the equation of the C is maximum plus minimum by 2. So the maximum is 17.3 and the minimum is 4.5. So we'll get the value of C is 10.9. And determine the time in the height of the maximum is 8 hours 21 minutes, and the height of the minimum is 2 hours 8 minutes. So minus 8 hours 21 minus 2 hours 8 minutes, so we'll get 6 hours 13 minutes. And 6 hours plus we will need to convert that minute to hours, so we need to divide that by 60. And so we will be convert to hours, is 6.22 hours, and the time from low tide to high tide is 6.22 hours, so which is half of the period, and so we need to multiply by 2. So the time is 12.44 hours, and we will get the period is 12.44 hours, and the equation of the period is 2 pi by k, and we'll get the k is 0.505, and the maximum height of maximum is 8 hour 21 minutes. So the to we'll find the horizontal translation, which 8 hour 21 minute. So 8 hour plus minute, we need to convert minute to hours, so we need to divide it by 60, so we'll get the d is 8.35 hour, and the equation of the h of t is 6.4 cos into 0.51 into t minus 8.35 plus 10.9 is for B, and for number C is determine the height of the tide relative to the pier at 11:30 and give your answer to the nearest 0.1 meter. So at 11 hours 30 minutes, so we need to convert that minute to hours, so we'll get 11.5 hours. And using the equation h of t equal to 6.4 cos into 0.505 into t minus 8.35 plus 10.9, so the time is 11 hours, so t is 11.5, and I will get the height is 10.8 meter. This for number C, and for number D is about needed depth of at least 12 meter to dot at the pier, and so h of t is 12 meter. Using the equation h of t equal to 6.4 cos into 0.505 into t minus 8.35 in plus 10.9, so the h of t is 12 equal to 6.4 cos into 0.5 into t minus 8.35 plus 10.9, so we get the t is 11.12 hours, and we need to convert this hour to minutes, so we get 11 hours 7 minutes. And using the point, we draw the graph at 2 hour 8 minutes. We need to convert the minute to hour, so we get the time is 2.13 hour, the height is 4.5 meter, and at 8 hour 21 minutes we get the will be convert to hours, so we get the time is 8.35 and the height is 17.2, and at t equal to 11.5 hour we get the height is 10.8 meter, and at t equal to 11.12 hours the height is 12 meter. So using the point, we draw the graph. This time high graph, and in the graph we can see that the boat will be able to dock at approximately 5 hour 35 minutes, and must be leave at approximately 11 hour 07 minutes. This is my unit 4 mid-unit assignment. Thank you for watching.